Right, so I'm halfway up a mountain. Yesterday was raining very heavily, like a kind of typhoon type weather. So as you can see, on a mountain, that way's up and this way is down. You see what happens? Water runs down. It goes from the top of a mountain down to the sea. Thank you. So here I am cruising along on my bike, one-handed, with a camera in the other hand, negotiating traffic and other variables, and I'm using my senses to do so. Oh, see, got to negotiate. Granny there with her bike, traffic lights, moving vehicles, steering one-handed. So yeah, I think I can trust my senses. So it's too windy outside, so I've come back inside because the camera was picking up too much crackle. But anyway, what I was trying to say, I was trying to express about trusting your senses. So if I got on the bullet train, right, that's the fastest moving vehicle apart from an aeroplane that I've ever been on. And in regards to an aeroplane, you're going at what, 600 miles an hour, something like that, I think is the land speed that you're doing on an aeroplane. You feel it, you feel that movement. On a train, on the bullet train, that's going at 250 kilometers an hour at its fastest point, or thereabouts. You feel it. You feel that movement, right? So people say, well, you know, if we were rotating, we would, if the Earth was rotating, we'd feel it. And then the counter argument to that is no, but the atmosphere is moving with the Earth. So for the same reason that you don't feel the wind when you're sitting on a train or you're moving in a car, is because you're contained. Okay, so we're contained. My point being is, the other argument is you don't feel the spin because the spin is so perfect. Well, if I were to stretch out that train to go from one point around the equator back to the next, and then that train is moving at the same speed, you're going to feel it. You're going to feel the movement of that vehicle that you're sitting in. Yeah, okay, so the argument, again, repeating myself again, the argument they give you is, no, you feel a plane because there's some vibration, there's some movement in the turbulence in the air or whatever. That's why you feel that airplane is moving. You feel a train moving because it's running on rails, and of course the ground it's moving over is not perfectly flat. That's why you are aware of doing that speed, and you can't deny that those points are true, but you would still feel that movement, I believe, if the rails you were moving on were perfectly flat, and the mechanics of the train meant that you couldn't feel any kind of movement. Your body would still know that you were moving through space at that speed. It would feel that, it would be aware of that. Again, they're telling you to deny those senses, and okay, so we're spinning east to west, or west to east rather. West to east, right. So we're spinning, but we're at an axis. Now, why the fuck does that axis never change? Why is that axis fixed? If I hit a baseball, of course, once my bat makes contact with that ball, the ball's gonna spin in one direction. I would suppose into the opposite direction to my swing. I'm going to put a spin on that ball, but the axial rotation of that spin, I would imagine, would change, would it not? I don't know. I'm not a scientist, and I didn't come up with this bullshit model. But in this bullshit model, we are flying through the universe in that direction with a spin. So in the same way that if you hit the baseball goes off, it's got a spin on it, right? But it's also going through the universe. Now, are you telling me that that spin is going to stay with an axial point that never changes? And I remember when I was a kid, I used to have that thought going through my head when a teacher or an adult would give you the explanation of, oh yeah, we get summer and winter due to the fact that the axial, we're at I can't remember the degree. Is it like 27 points? I don't know, 30 something. I don't know whatever the axial tilt is. We're always fixed. That never changes. We're flying off through the universe like a bullet out of a gun, yet we spin east to west year after year since the beginning of time, and that there's no wobble in that axial tilt. It's fixed there. And I remember thinking as a kid, that's weird. Why? If north is north is kind of up in my mind. Why is the North Pole off to an angle? How does that work? Why? There's no... I couldn't get my head around that as a kid, but, at some point you just give up thinking about those kind of things. But now I'm back onto that point. Can someone please tell me, why does the axis of our planet stay fixed? Especially when we're supposed to comprehend the model that we're flying off through the universe. Like I'm repeating myself again, likened to a baseball being hit across a park. Are you telling me that if I hit a baseball across the baseball park, that it's going to spin consistently in one direction until it runs out of energy? But is it axial? Is the rotation of that spin moving? I think it probably is. I don't know, I can't prove that. I'm probably going to go away now and watch some stop frame footage of baseballs being hit across the park. But yeah, I think if we were spinning, our senses would let us know. So the thing that pisses me off the most is the constant reapplication of globe bullshit. So my counter offer to such a thing is my reapplication of the opposite of that propaganda. This motherfucker's pushing space onto kids. You should be ashamed of yourself, mate. Okay, so the building I'm trying to focus in on is the Tokyo Metropolitan Building. It's a bit hazy today, but you can see the two-pronged building that's in the center of the shot. That's what I'm looking for.
Can you check your water? Oh, it goes down to 6. Was it the Coriolis effect?
Yeah. That's the same fucking thing that they tell you, like a sniper shooting, like shooting north to south has to factor in the spin of the earth for his fucking bullet. You know, it's like, fuck.
I don't know a sniper.
I think it's easier to meet an Australian
Yeah,
than a sniper.
it's maybe easier, yeah.
Yeah.
If you want to kill 2 birds with 1 stone, meet an Australian sniper and ask him all your questions.
Yeah. Excuse me, Mr. Australian sniper.
Yeah.
When you're shooting north, do you have to worry about which way your sinks? I mean, which way the bullets?
Nah, mate.
Nah, mate.
I've had a bit of a drink. I'm
a bit fucking pissed, mate.
I'm sorry. Australian sniper.
There's not a real big market for Aussie snipers these days, mate. So, I had this thought about tides, and, well, you see this dripping into my coffee pot. That kind of shows you again how a tide could work in a contained system, as in the waves spread out until they hit a wall and then they come back in again. You see, as the drop drops, it goes out, hits the wall, comes back in. Now, if you scaled this up to a much bigger size, added some continents into it that had obviously higher land mass than the water, you might be, just might be, on track to explaining how tides work in a flat contained system. Okay, so that is the supermoon, January the 1st, Tokyo. Now, it's still daylight. The sun has gone down over there, but technically still up. It's being kind of obscured by those buildings. So we've got the full sun still lighting the sky, and we've got a full moon bigger than usual. Maybe my camera's not really, it's not got a great zoom on it, but trust me, that is massive compared to usual. That is not getting its light from the sun.
Anyway, have a good 2018, people. Keep up the research. Keep up the activism. Don't accept the bullshit. Keep it real. Demand the truth.